Have you ever wondered why some plants thrive in your garden while others struggle? The answer might lie beneath the surface, hidden in the delicate balance of your soil's pH. Just like we need a balanced diet, plants need a balanced soil pH to absorb all the vital nutrients they need. When the pH is off, it's like trying to fit square blocks into round holes. The nutrients just can't get where they need to go. This can lead to stunted growth, yellowing leaves, and even plant death. So before you start planting, let's delve into the world of pH and discover how to give your plants the perfect foundation for a blooming good life. Imagine a bountiful buffet laid out for your plants, filled with all the essential nutrients they crave. Now imagine that the door to this feast is locked and the key is the right soil pH. When the pH is in the ideal range, usually slightly acidic to neutral, the gate swings wide open and your plants can feast on a nutrient-rich smorgasbord. However, when the pH becomes too acidic or too alkaline, the gate starts to close, restricting access to vital nutrients. For example, iron, a crucial element for lush green leaves, becomes less available in alkaline soils. On the other hand, phosphorus, essential for strong root development and flower production, becomes less available in acidic soils. By maintaining the right pH balance, we can ensure our plants have a constant supply of the essential nutrients they need to grow strong, healthy, and full of life. Now that we understand the importance of pH, let's put our knowledge into action with a simple yet fascinating experiment. We'll be using common seeds like radishes or beans, known for their quick germination and easy-to-observe growth patterns. By subjecting them to a range of pH levels, we'll witness the impact of pH on their height, leaf color, root development, and overall health. This experiment will provide us with valuable insights into the optimal pH range for these plants and equip us with the knowledge to make informed decisions in our own gardens. So, grab your gardening gloves, put on your scientist hats, and let's embark on this exciting pH adventure. Before we begin our experiment, let's gather our gardening tools and transform ourselves into plant scientists. Here's a checklist to ensure we're fully equipped for our pH adventure. First, seeds. Choose fast-growing seeds like radishes or beans, which will show visible results quickly. Next, soil samples. Collect several samples of soil with varying pH levels ranging from 4.5 acidic to 9.0 alkaline. Your local garden center can help you with this, or you can purchase pH testing kits to determine the pH of your own soil. Then, lime and sulfur. These are our pH adjusters. Lime will help raise the pH of acidic soils, making them more alkaline, while sulfur will lower the pH of alkaline soils, making them more acidic. You'll also need pots. Use small pots of equal size for each pH level we're testing. Make sure they have drainage holes to prevent waterlogging. A pH meter is essential too. This handy tool will allow us to accurately measure the pH of our soil samples and ensure we're creating the desired pH environments for our experiment. Now comes the fun part, creating the different pH environments for our seeds to grow in. First, we'll label our pots clearly with the pH level we intend to create in each 4.5, 5.5, 6.5, 7.5 and 8.5. Next, we'll fill each pot with its corresponding soil sample. Now we'll use our lime and sulfur to fine-tune the pH of each pot, carefully measuring with our pH meter until we achieve the desired levels. Once our pH-adjusted soils are ready, it's time to plant our seeds. We'll sow a few seeds in each pot, ensuring they're planted at the same depth. Finally, we'll water each pot thoroughly with our distilled water, being careful not to overwater. Now that our pH playground is set, we need to find a sunny location where our pots will receive consistent sunlight throughout the day. With our experiment set up, we can now sit back, relax, and let the power of pH work its magic. With our seeds tucked into their pH-adjusted homes, the real adventure begins. Observation! Like proud parents, we'll be keeping a watchful eye on our little seedlings, noting any changes and documenting their progress. Each day, we'll grab our notebooks and carefully observe our plants, paying close attention to the following. Plant height. We'll measure the height of our plants from the base of the stem to the tip of the tallest leaf. recording any differences in growth rates between the different pH levels. Leaf color. We'll note any variations in leaf color from vibrant green to pale yellow, as this can indicate nutrient deficiencies or imbalances caused by pH levels. Root length. At the end of the experiment, we'll gently remove our plants from their pots and examine their root systems. We'll compare the length and density of the roots in each pH environment. Overall health. We'll observe the overall health and vigor of our plants, looking for signs of stress such as wilting, leaf drop, or stunted growth. By meticulously recording our observations, we'll gather valuable data that will reveal the impact of pH on our plant's growth. After patiently nurturing our plants and meticulously documenting their growth, the moment of truth has arrived, analyzing our results. By comparing the growth patterns and health indicators of our plants across the different pH levels, we can unlock the secrets of pH and its impact on plant growth. We can create charts and graphs to visualize our data, making it easier to identify trends and patterns. We might observe that plants grown in the slightly acidic to neutral pH range, between 6 and 7, exhibit the most vigorous growth with taller heights, lush green leaves, and robust root systems. Conversely, plants grown in the more extreme pH ranges, either highly acidic or alkaline, might display signs of stress, such as stunted growth, yellowing leaves, and weaker root development. Our results might reveal that radishes, for example, thrive in slightly acidic soils, while beans prefer a more neutral environment. This valuable information empowers us to make informed decisions when planting these vegetables in our gardens, ensuring they have the optimal pH environment to flourish. By understanding the fundamental principles of pH and its impact on plant growth, we can create a thriving garden where every plant can reach its full potential. Our pH experiment has not only been a fascinating journey of discovery, but also a practical lesson in optimizing our gardening practices. Before we even sow a single seed, we can test our soil pH and make necessary amendments. If our soil is too acidic, we can incorporate lime to raise the pH. Conversely, if our soil is too alkaline, we can add sulfur to lower the pH. By fine-tuning our soil pH, we're essentially setting the stage for healthy plant growth and maximizing our gardening success. Furthermore, understanding pH allows us to choose the right plants for our specific soil conditions. By working with our soil's natural pH and selecting plants accordingly, we can create a harmonious and thriving garden where every plant has the best chance to thrive. Remember, gardening is a partnership with nature, and understanding the science behind it empowers us to become better stewards of our green spaces. Our journey into the world of pH doesn't end here. This experiment has opened the door to a universe of fascinating questions and further explorations in the realm of plant science. Like any good adventure, it's just the beginning of a lifelong journey of discovery. Here are a few ideas to quench our thirst for knowledge and continue our pH adventures. Asterisk species-specific pH preferences. We can delve deeper into the specific pH requirements of different plant species. Do tomatoes prefer a slightly more acidic environment than peppers? How does pH affect the growth of herbs? The possibilities for experimentation are endless. pH and nutrient interactions. We can investigate how pH affects the availability of specific nutrients such as nitrogen, phosphorus, and potassium. By understanding these interactions, we can tailor our fertilization strategies to meet the specific needs of our plants. Sun, pH, and environmental factors. We can explore how pH interacts with other environmental factors such as water quality, temperature, and light intensity. This holistic approach will provide us with a comprehensive understanding of the complex interplay of factors that influence plant growth. By understanding the science behind gardening, we can unlock the secrets of a thriving garden and cultivate a deeper appreciation for the wonders of the natural world.